I know there's like two camps of people. The people who like ASMR and the people who get freaked out by mouth sounds.
Oh, yeah. I don't like little mouth sounds. No. In particular, podcasts, if you've got that, it's a lip smacking thing. I'm like, no. Edit it out. Oh, hope we don't do that. Welcome to another episode of OTMT, a podcast about, what do we do here, Surma? Web things. I am Jake.
And I'm Surma.
And Shopify lets us do this, and we're ever grateful.
Thank you, Shopify. I think it actually has been too long without a bathroom story, and there is a story that I need to share with you.
Oh, I'm ready. I am in the receive position for your bathroom story.
Are you on the edge of your
throne? Absolutely.
This was when I was on vacation, and I was in like a restaurant and wanted to wash my hands. It's not even, not even bodily functions, just wanted to wash my hands. Went into really nice looking bathroom, like when they have, like proper cotton towel stacks and those kind of things. And the sinks were really quite interesting. So it was like a big mirror on the wall, like basically the entire wall was just one mirror. And then the sinks were at a 45-degree angle going into the wall. So you had like one super long sink in front of you, effectively. So multiple people could wash their hands next to each other.
I see. Kind of trough sort of thing.
Yeah, exactly, like a trough.
Wait, hang on. This was definitely the sink and not the urinal.
Yes, I did double check.
Okay.
But also, wouldn't it be weird if you had a urinal with a big ass mirror in front of you? And by the way, the trough itself was also a mirror.
Oh, so you're gonna get all angles of your of your little lad.
Yeah, if you need a good checking out, that's the place to be. So you kind of hold your hands into this trough, and like the trough goes a bit under the wall, and then suddenly water comes out. Like you kind of know them from like airports, kind of like auto sensing things.
Oh, I see. Yes, okay, I'm with you.
And so I was washing my hands, admiring the undersides of my hands in the mirror of the trough. And suddenly, from below the sink, from basically inside the wall, hands appear.
What?
With really nicely done red nail polish. And I let out a little yelp, and that's when I understood that this wall was shared with the ladies' room, and from both sides, basically the wall contained the taps, and then the trough came in from both sides with a cut through in the wall, and you could watch each other's hand how they wash.
No, I want my money back. I don't know. No, I disinvest in this idea. Like, because there's a chance of just, two people going in at the same time and a hand collision, and I would have to get a flight back home. Yeah,
like a nice little post-bathroom break handshake. Is that not what you're looking for?
Bathroom break handshake. I mean, now I hear it rhyming. I like it.
Now there's a niche, there's a brand. Yeah, it really has burned itself into my brain as an startling experience and then when you keep watching and you realize there's more hands, it's just like these disembodied hands kind of ringing around each other to wash themselves. Very Addams Family. It was surreal.
Does sound like the kind of thing like someone who works in finance in the city would say. It's like, excuse me, lads, just going off through a bathroom break handshake. If you know what I mean. I don't know what you mean. No, you know what I mean. I don't know what you mean. Yeah, you know what I mean. Yeah, that's
probably also the people who would enjoy this the most and not be startled by it.
Yeah, they built it. Yeah, absolutely.
So instead of analyzing this further and re-traumatizing myself, should we talk about tech, I suppose?
Oh, wait. What? I don't like change, Surma.
No, I know. Well, it is useful for web development. So, I'm going to talk about Nix. So a couple months ago, I think, I don't know how long ago it is now, actually, I did an episode about Bazel, which also, not really web development, but kind of tangential because it can be used for web development. And Nix is the same. It's also a build system, and I have been learning it, and I have become a big old fan of it. And therefore, I'm now here to kind of like talk a bit about why, because I do think it is really interesting to think about. It genuinely has made me question certain things about why our current incarnation of operating system, build systems, work the way they do, because some of these things seem kind of like bad choices in retrospect.
I do think that there's so much of the web build systems that we use that kind of haven't maybe learned enough from some of these grander scale systems. So I'm excited to hear more about this.
It even made me question some of the choices that, for example, the current Rust compiler toolchain makes. Like, not question it, but you kind of realize they're all built on assumptions that have been around for ages and they kind of work, but we could be doing so much better.
Before you dive into that, is it, I feel, has Rust now switched into that thing where people are actually critically analyzing it? I'm seeing a lot of this, like a lot of Rust criticism all of a sudden. It felt like it has been for 5 years or however long. It's like, wow, this is just revolutionizing everything. We should rewrite everything in Rust. And it feels now that it's kind of got to, it's sort of past that hype, peak. And people are like, this is, maybe we should be using Zig or...
Yes and no. I feel like it is becoming cooler to not like Rust. To an extent, that's a deserved counter movement, because there was also some undeserved overhype. Like this whole, the Rust community, I think, is really great. But there are also a couple of traits that for some reason are very present in many people in the Rust community. Like what you just said, the whole this should be rewritten in Rust and it would be so much better. Most of the time, that's just a shitty thing to say. Like, a piece of software has been around for ages and working well and has been written in C or C++. Will it get better just because it's now rewritten in Rust? I doubt it. Like, I personally would love it because it makes the code much more approachable to me. Like, I feel much more comfortable jumping into a Rust code base than I do into a C or C++ code base. But that's just the nature of being fluent in a language versus a language that I'm not comfortable or fluent in. Like, yes, I know some C, I know some C++, but I not once really in the last, 15 years have I written a side project in C++. I've written a whole bunch in Rust. So that's, I think you're right. There's more people being more vocal about things that are not great in Rust because, it has introduced many new things to the ecosystem and to coding, but of course it's not perfect. But I, as always...
Okay, I derailed you.
Yeah, let's talk about Rust. So how do I start?
What is Nix?
Well, it's a build system, innit? So I tried myself at making a YouTube video, and I'm not sure if... So people seem to like it, but I'm not sure if they liked it because of the way I explained Nix or because I did nice animations, because I discovered this cool thing called Motion Canvas, which was really fun to use to build basically a video with, you can also use to build presentations.
It is really nice. We'll link to that.
Yeah, and I'm not I literally feel bad for taking credit for how nice the animations look because I just plugged things together. Anyway, my plan is not to just rehash the video. In the video, I really explain step by step how Nix was started by a guy named Eelco Dolstra throughout the work on his PhD thesis, and then the individual building blocks. This is a podcast. I don't have visuals. So I want to focus a bit more or speed run a bit through that to get to where we could be using it in web development potentially, because that's, I think, where it gets interesting.
I have to say, when someone says, if you want to know about how this build system works, read my PhD thesis. I cannot close the tab fast enough.
It does sound scary, doesn't it? And I will say, sadly, that is kind of on brand for Nix a little bit. The documentation situation on Nix is not good. You don't have to read the PhD thesis.
All right. Okay. Good start.
But you do have to dive into, standard library code to figure out how to use it sometimes. That's definitely. And everybody, I feel that likes and loves Nix immediately acknowledges yeah, our documentation is not good. It's not good, mate. So that's something that hopefully will get better. And also, yes, it is a PhD thesis, or it is the product of a PhD thesis, which means it has its origins in academia. And even that shows it involves a purely functional programming language that looks a lot like or reminds one of Haskell. And that's also not everybody's cup of tea. That being said, he designed a language for this build system, and I'm not sure that was 100% necessary, but the language is so small that I felt comfortable with it very, very quickly. But let me take a step back before we talk about the language itself. Basically, the problem that this guy, Eelco Dolstra, was looking at for his PhD thesis is the general problem of how do I get my code or my software on machine A to run on machine B. And that actually isn't necessarily easy to do in a reliable way. When you install Chrome, you download a binary. And you have to make sure you download the one for your operating system. If you download the Linux one and you're on Mac, that will not work. That's the first instance already where this model of deployment can go wrong. You need to make sure that you compile the right binary for the target system. And then often these binaries rely on certain libraries being present on the machine it's supposed to run on. And if these libraries are missing or even just have the wrong version, then it will likely not work. So this whole thing of just like copying binaries around is not a good system. But people like you and me, we work in open source. That's very different, where you have the source and you can just copy the source code over and compile that. And I think that actually works fairly well. But I think even there, most of us have experienced the problem of just because it compiles on my machine doesn't mean it will successfully compile on your machine.
Yes, and we hit this a lot in Squoosh, because when we were dealing with the various image libraries, and even two of us using Mac, works on one machine but not the other.
And I will talk about Squoosh later, because that's exactly where I want to use Nix in the future. But even with just when you have Node or NPM libraries like Sharp that pull in C++ code, or maybe even, rely on certain files being present, but, on Windows, everything is different. Like, you can already tell just because something compiles on my machine doesn't mean it will compile on your machine. And even then, even if it compiles on both machines, doesn't mean that it will run. Like, if we have a JavaScript code base and we both run the exact same version of Vite to compile the exact same source code, they probably will spit out the exact same result. And yet, because you are on node 20 and I'm on node 22, it may not actually work, because that code that was output relies on a specific version of the runtime, or again, on system libraries. Just if you think about one machine may have FFmpeg installed and the other one doesn't, but you rely on FFmpeg being there.
And then Docker came along and solved the problem.
And everybody was happy. To an extent, yes. But also, kinda no. I mean, so I think Docker is, in its simplest terms, you can think about it spins up a virtual machine. And so if everybody boots up the same virtual machine image, that means you can compile the software reliably in there, because the entire environment is snapshotted basically in that image of the virtual machine effectively.
Yes.
But if you want to run the software outside of the virtual machine, you're kind of back to the same problem. So unless you also plan to run the software inside the virtual machine, that problem is still kind of there, because now you're back in the world outside of the virtual machine where you don't control what exactly is and isn't there. But you're right, like Docker is one of the things that's been around that kind of has made these things a lot more interesting. But also, and this is where, and I think I'm going to jump ahead here a little bit, because we had a problem we use Docker in Squoosh. So in Squoosh, I should probably set the context here, we have loads of different image codecs. So something that takes a bitmap and converts it to JPEG, another one to AVIF, another one to JPEG XL. And those are all, C++ or Rust programs that we have in there. And we use Docker to turn those into WebAssembly, because we did not want to force people to install all kinds of compiler tool chains and libraries to be able to work on these image codecs. And for that, we use Docker. So inside the Docker container, we set up basically the development environment to work on the codecs and to also compile them. And then we have WebAssembly, which kind of ensures that the binary works outside the virtual machine as well.
Yes.
But inside the virtual machine, we still need to somehow codify how code is supposed to be built. And for that, we use makefiles. basically it's a bash script where every individual step take these bunch of C files and compile them to a static library, take these bunch of C files and compile them to object files, and then link them all together to form a WebAssembly file. And we kind of like wrote these steps out with a make file, more or less. And make files, have been around for ages, really well understood, and they work quite simply through the mechanism of timestamps. So you write your build instructions and you tell make, these are the input files that this build step needs, and these are the expected output files. And if any one of the input files has a newer modify date than the output file that we have, we need to rerun the step.
Yeah.
And that sounds pretty good on paper. But the reality is, the amount of time that we lost hours to trying to figure out why something wasn't working until we realized our code changes are not actually being incorporated into the output, because somewhere along the stack of all these different build steps, there was a cache that just cached the output and didn't actually use the new output or something like that. We have lost so much time to that.
I mean, it's the eternal problem of any kind of build system, right? Like, just, it's not unique to Make.
No.
The amount of times I'm deleting TypeScript caches or whatever.
And that's what I was praising so much about Bazel, where I felt like their caching is rock solid. Not once did I need to, nuke a cache to fix a build error. It was always going to be the exact same build error because they got caching right. And I feel like Nix does the same.
Okay.
And that's, again, where then suddenly, to me, it becomes useful. So, so in Squoosh, we had this problem. We used Docker to have a very consistent, shareable development environment. But then we used makefiles, glorified bash scripts to do the building. And going back to Nix and the PhD thesis, this is kind of the observation that Eelco did as well. The problem with all of these tools is that on the one hand, they don't accurately necessarily track which steps need to be redone or rebuilt. And also that in many instances, it doesn't fully capture any variable that can affect the output. So for example, in makefiles, you would just write, hey, take Clang as my C++ compiler, put these files in, and take the output. But nowhere do you specify which exact version of Clang it is.
Isn't that what like an auto config? Isn't that what that's supposed to deal with? Or
yes and no to an extent. I think it covers part of it, but it's still not, bulletproof in that sense. And so what Eelco did when he developed Nix is basically by tackling this problem from two sides. The one is to design a domain-specific language that is specifically designed to express how software is built. In that sense, it is like Make, but on steroids. And these kind of like build recipes in Nix are called a derivation. And that's probably academia leaking through a little bit, but it's a build recipe, right? And it is a bit like Make in that you actually do end up writing bash scripts or scripts, abstraction of bash scripts, but basically just as a way for you to orchestrate these individual tools, similar to Makefiles, where you invoke different tools and tell them which files to consume and where to put the output. So really what this is in that sense, again, it is still quite similar. These derivations, as they're called, they have inputs, which is usually source code, and build tools. So the build tools are part of the input. They're exactly specified and they produce outputs. Mm-hmm. And here's where now the tracking of dependencies gets in. And I think it's really interesting that build recipe together with a list of the source files that it consumes and the tool that it needs gets cryptographically hashed. And I'm not going to go into details how, but basically I'm going to handwave those details so that then this build recipe can be stored in what is called the Nix store. That's really just a folder on your disk, but that hash becomes part of the name. So in that sense, it's a bit like Git, where it's content addressable.
Okay.
So if something changes in your derivation, it now gets a new name because the hash will be different.
And that could include like the version of the C compiler that you're using.
Yes, exactly. Because that's exactly where it gets kind of interesting and recursive with Nix, I feel like, because both the source files that you want to compile as well as the tools must come from the Nix store. You're basically not allowed to take something from anywhere else. So only things that have been hashed you can use in your build recipe. And if you have this item in your Nix store, you can just use it. If you don't have it, because this hash also incorporates the build recipe that this item was built with, Nix can deduce how to create this item in the Nix store. So either you have this exact version of Clang on your system in the Nix store and you can use it, but if you don't, Nix can figure out how to build this exact version of Clang so that you have the exact same version of the compiler and the exact same version of all libraries and the exact correct source files to produce a specific output. And that sounds very tedious, but it is actually designed in a way where it's kind of natural to write this way.
So it's Nix all the way down. Like, every single part of your tool chain needs to be built in advance or presumably got from somewhere.
Yes. It is, in that sense, they bootstrap themselves up to the point where they are completely independent of the system. And that makes sense because the system is one of the biggest variables that differs between, well, systems, where these kind of things, it works on my machine but not yours. The origin often is differences in the system. And so he has designed a system where that is kind of abstracted away.
I was going to say, at some point, there's difference between operating systems, right? Like, if you're running this on Windows or Mac or Linux, you have differences in file name case sensitivity, for instance.
Yes. So, for example, the operating system is part of the hash. So that means if I'm building something on Windows, it will, by very definition, it's a different dependency chain all the way down than one on Darwin because it is fundamentally a different operating system. It doesn't incorporate the version of the operating system, but I think that's all right because operating systems like kernels are stable in their APIs, or they're just assumed to be stable. And I think that's a realistic assumption.
You've got to stop somewhere, right?
Exactly. Exactly.
Yeah. Operating systems don't tend to change their file encasing or the sort of basic file access APIs.
Yeah. So they add stuff, but they barely break stuff.
Exactly.
Breaking user land is a big no-no when it comes to operating system. So every piece of software that you express with Nix, needs tools to build it. And then these tools themselves must be buildable with Nix. Otherwise they wouldn't exist in Nix. And this goes all the way down to like a very small, the smallest possible seed of kind of like impureness where there's like one tiny, very basic, I don't know, maybe it's an assembler, I don't know, that is just pre-agreed to be accepted and will just be downloaded as a binary file or something. And everything else is bootstrapped from there. And that's because Nix is all about building software. And so it allows you to build the exact same version of this piece of code that you're looking at every single time. Of course, this sounds really, really slow, and it would be really, really slow if every time you'd have to like start from scratch and basically invent the universe. Mm-hmm. So the other thing that Eelco also looked at in his thesis is how you can do binary caching in a secure manner. So that basically if one machine somewhere has already executed the derivation, like built the output, that you can just share that rather than having to rebuild it yourself. And there's all kinds of things that you need to think about, with like cache poisoning and other weird things. And he looks at all of it in the thesis, but basically he found a solution that basically you could set up shared caches between systems that if one machine has already done the work, you don't need to redo the work, provided you have the same operating system.
Okay, so this is a little similar to downloading a Docker image, right? Except, without the, it comes with the operating system sort of attached. Yeah.
Yeah, it is in that sense. But the other part is that it is not just about setting up a system. It's also about executing build instructions, right? Like it's all about build recipes. So with Docker, you get a Docker file in a sense, maybe, but even there, those are not, if you think about it, even a Docker file it seems to be sufficiently reproducible considering we all use them in environments. But really, if you look at Docker files, they often just, do apt-get install, yes, which just downloads whatever is currently in that Debian package repository. And technically, it will definitely not be byte equivalent to what my Docker image looks like necessarily if we execute.
It'll change over time. Yeah, that's fair.
And again, this is like the academic level of accuracy, and maybe that's not necessary, but I think in this case,
I think it's a selling point. Yeah, no, this is good.
Sharing these binary artifacts, there is stuff to think and to read about security. I'm not going to get into that, because where it then gets interesting next is that, now we have Nix, we can build software, we can bootstrap our way up from nothing and so it was originally, and you still feel that kind of tailored for downloading tar balls of C or C++ source code and building that. But from there, you can kind of like continue building and build software packages like Make or Clang or whatever, but also build other language tool chains for like Go or Dart or Rust. And that's what Nixpkgs is, which is an entire collection of build recipes for all kinds of software. And I think it is still currently by a large margin the biggest collection of packages and the most up-to-date one. So if you compare it to, Debian's or Ubuntu's apt, or to Arch Linux's AUR, or even to Homebrew, these are all at about a third of the size than what Nixpkgs has.
That's incredible, because I've heard of those other things, but I hadn't really heard of Nix until you and other Shopify folks started. So it's kind of like, how has this thing got so big it sounds very big without me hearing about it, because come on. But I don't know. I feel like that might be representative. I feel like more people certainly listening to this will have heard of Brew, but not of Nix.
There's two factors here. The one factor is that it's only achieved this place in the ranking in the last 2 years, I want to say.
Oh, okay.
It was, I think, a proactive effort where they basically now have a system where each build recipe has a script that will automatically update the build recipe itself if there is a new version pushed to, that piece's software GitHub repository. Previously, a human would have to step in and update the thing. But most of the time, software projects just like do minor fixes. So compiling a new version is kind of just, bump the referenced Git commit, and then the same build recipe will probably still work. So that's one thing they have done, where most of these recipes will now be automatically updated on an almost daily basis via CI. And the other part is, Nix is just weird to an extent. It is actually a bit scary to install. Like, one of the implications of wanting to be able to share your build output with other users on your system, or even people on the internet, is that the building is actually executed by a different user on your system. So the Nix installer creates a bunch of dummy users, and on macOS it even creates a separate partition to prevent being nuked from your disk, because macOS is very precious about what gets to be in your, in slash on your file system. And it's all legit. It's all not dangerous, but I think that is definitely a deterrent for many people. If you start the install and goes like, hey, I'm going to create 30 users, 30 groups, and a new partition on your Mac hard drive.
Yeah, that's a big ask.
Yeah, I only do it now because, I know it's worth it for me, but I think if you showed me this like half a year ago, I would have said, nope. Especially on my work machine, but even there, I've done it now.
I imagine the PDF copy of the PhD thesis goes on the partition as well, right? Opens at startup and prints at startup.
Oh yeah, it prints it every time you boot. Gotta do it. So Nixpkgs is this collection, huge amounts of software in there, and also there's stuff in there that lets you, if you were the author of your own Nix build recipe, makes your life easier. So instead of having to figure out how to compile, Node or NPM yourself because you want to build your own Node project, Nixpkgs is full of helper stuff for the Nix language to do Rust projects, Node projects, Go projects. It's all kind of in there. There's something you might even call documentation around it. But yeah, there is definitely support in there to help you build your own projects using Nix if you need these kind of benefits. And that's exactly why I've been looking at it for Squoosh. Because another problem we had in this thing that we're working at is, often our codecs come at the very least as a 2-step compilation process. Once you compile the library that contains the codec, and then you compile our glue code that, provides the standardized interface that the Squoosh app expects in a WebAssembly way to invoke that library. And often the work that happens is mostly on the glue code, because we don't develop the codecs ourselves. We just take those off of GitHub and compile them to a library, and then we write the glue code and have to figure out how do we invoke this library correctly. But in many cases, it seemed like we end up recompiling the library over and over, which takes a long time because those are, quite big, quite complex. And similar to what I was a fan about in Bazel is that you can break out these individual build steps into singular units of execution, and therefore they're cached individually. So once they get built, they will never get rebuilt unless the inputs file change. And that's kind of what I've been looking at for both our Rust-based codecs as well as our C++ codecs in Squoosh.
Oh, you've been looking at this with Nix in mind. Ooh.
Yeah, I have a branch, and I think because, well, here's the reason why, right? Like, so far, we have been committing the WASM binaries to our repository in Squoosh. Just because most of the time, if we're going to get contributions on Squoosh, it's going to be on the web app part. Just because WASM is just more niche, I guess. Like, it's, and probably also those things don't need, if once they work, maybe an update to a newer version of the codec, but it's a lot rarer that something needs to be changing there. And so we just committed them. And I always feel iffy about committing binaries to a repository.
Oh, absolutely.
But what is the alternative? Because building every codec every single time would at the very least blow our, CI runtime, but also it would just make it not fun for people to contribute. You clone the repository, you run npm install, and the first time you do npm start or run def, whatever it's called, and then you have to wait for, I don't know.
There goes 45 minutes. Yeah.
Yeah, like that's not cool. And like I said, like even if we were to invoke Docker, then it's like it works maybe great for a fresh build, but once you start working on the code, there's often these caching problems. So yeah, that's why I'm looking into that, because on the one hand, with the hashing of the sources, if you had it built once on your system, it would be very fast afterwards. But also, we could set up our own remote cache. Like there's actually a whole website called CacheX that does it for you and is free for open source projects. But you can also just use a GCS bucket, and basically we could just allow people to clone the repository, which would also get quicker if the WASM binaries weren't in there anymore. And once they do npm run, we would invoke Nix, but then it would just end up downloading the result rather than actually doing the build. Now that presupposes that they have Nix installed, which probably would lead us back to Docker. So that's also not a perfect solution. I'm not sure yet, but I'm mostly exploring it as a means to address the problem of why am I not able to fix the bug that I'm investigating? And then an hour later you find out, oh, there's some caching going on somewhere along the stack that maybe you didn't know about, or that wasn't supposed to be caching, but it's caching for some reason anyway, which is has just been a massive pain point.
Yeah. And there is a security element to it as well, because I know when we've had PRs that include like the changed code and the WASM binary, it's like the first thing I do is go and rerun that. And sometimes it comes out with a slightly different WASM at the end, but it's innocent. It is just the problem you mentioned. The tool chain is not stable. But, a bad actor could come along and say, look, I've changed this piece of code and the WASM's changed, but the WASM is very different to what the the code is there.
That's actually a really good point in general. That's also what most of these helper functions for, Rust projects, Go projects, JavaScript projects do for you, that they download your dependencies for you and also put them in the Nix cache. So as an addition, projects like Rust or JavaScript nowadays have their package log file, which already protects against supply chains attacks. But if you were to run your own cache and then somebody goes ahead and unpublishes a package from NPM, if you still have it in your cache, you would still be able to build it because it's in there. And the other part is if there was a supply chain attack and somebody manages to somehow replace a version somewhere without doing a version bump, but with malicious code, all of that would be caught. And it's implemented at the Nix level. It doesn't need to be implemented at the language level that you're using. So if you're experimenting with a very new, young language or some other build tool that doesn't have this kind of protection built in, Nix can provide it for you. So this kind of security thing that you're mentioning, it provides it across the entire project. And I think that's actually also something really valuable, which is also one of the reasons why we are looking at Nix now for Shopify, to see if we can build our system with Nix. But that's early exploration, nothing I want to commit too much to publicly. Yeah, so that's something I've been working on. And I have to say, the Nixpkgs as a whole has replaced Homebrew for me on my system. Again, because there is a global shared cache for everything in Nixpkgs specifically, most of the time it's just downloading. So it is really quick. It has so many packages in there. And not only that, it's very easy to install an older version or a newer version, depending on what you need, because each of these packages expresses their dependencies so accurately down to a cryptographic hash that you don't run into this problem where you maybe have two pieces of software installed and one needs this new version of the FFmpeg library, and the other version doesn't work with this new version of FFmpeg, but needs the older one. But both versions of FFmpeg cannot coexist, which is something that has happened before.
Right.
And that I just find really, really appealing.
When I install things with Brew, and I can just use them on the command line, is that true for Nix as well? Does it do the path stuff?
Yes.
I don't like the way you said yes.
No, I know. So there's differences. One of the things actually, it is actually something I really appreciate about Nix. There is a command that you get by default when you install it called Nix shell. And you can just say Nix shell -p for package and say, for example, FFmpeg. And then it will, basically create a new bash shell for you. And in the shell, FFmpeg is suddenly available for you and you can use it. And once you go out of the shell, FFmpeg is gone again.
Right.
More or less like it was never on your system. So it's not like it has installed all kinds of shit to, your /opt/homebrew or anything. Like there's nothing that has been on your system outside of the Nix store. So there will be a Nix store item that is specifically for FFmpeg, but everything is contained within there. So that way you can actually try out something without having to commit to actually fully installing on your system. And then there's a command called Nix collect garbage, which will remove everything from your Nix store that you currently don't use anymore. You can also install it persistently with a command called nixenv. These are kind of like, I guess, not the best practices anymore, but they're the easiest to explain. So there's, every user gets their own so-called Nix environment, which you manage with the command called nixenv, and you can add Nix packages to this environment. And then they're just there until you remove them again. So that's how installing would work.
With the cleanup command, if I've installed like FFmpeg with particular flags or whatever, how does it know when I don't need that anymore?
With the Nix shell command, it knows it the second you close the shell.
Oh.
With nixenv, when you install a package, it installs it into your profile, which sounds very abstract, but basically, like I said, every user gets their own environment. And an environment is just a collection of symlinks. So basically, there will be a .nix profile folder that is full of symlinks with the different packages that you have installed. And as long as these symlinks exist, it knows it's still needed. And then it can obviously, track the dependencies all the way down and basically mark what is still needed in Nix store and remove the rest. And that's kind of how it works. And if you use nixenv to uninstall something, technically, I think you could even just remove the symlink. I wouldn't recommend that, but you probably can do that. If you then run nix collect garbage again, now the symlink isn't there. Now this package will not get marked as still in use, and then it will also get removed.
Okay. I think I get some of it. I need to get over exactly the thing you said of like, do you want to install 10 users in a partition? Especially on a work machine. I'm like, should I be installing a partition on a work machine?
Yeah, it is weird, but I haven't been told of it. I mean, you can, as always, run it in Docker first if you want to play around with it and get familiar with the commands.
Oh, that's fair.
To hint at something, there is a thing in Nix project called Home Manager. And I don't want to get too much into NixOS, which is a whole Linux distribution that put Nix at its heart, but I think it's more of a distraction. In Home Manager, basically, you kind of declare the setup of your machine. You basically say, these are my config files that I have in my home folder, like people used to have .file repositories, but it also lists, I want to have these packages installed. And then you can use Home Manager to just set up your machine and continually maintain the state. So when you want to install a new package, you just add it to your Home Manager config, and suddenly this package is now there and installed and set up. And if you get a new machine, you just run this config file on your new machine and it will be set up the exact same way. And I've done this a couple of times now. I've been playing around with a couple of Raspberry Pis at home, and basically being able to go on a freshly installed system and run 2 commands, and suddenly my entire environment is there. My Vim config, my SSH and GPG keys, all the tools I use are installed. There is something about that. And again, because it's all, hashed and tracked, it knows exactly whether your environment is currently out of date or not. It doesn't come without its drawbacks, but if I've nerd sniped people, they should take a look at that, because that's what I'm using now. I have my Home Manager config where every machine has its own little configuration file, and there's a couple of shared files when, because obviously I want the same Vim config on every machine, so I don't want to duplicate that. And that's what I use to kind of make sure my system is set up. And you can even install, just like with Brew, proper applications. So if you want to install Arc or Obsidian or Audacity, all these things are available. Even if they're closed source, some people have added them to Nix packages, and it's just, it's a form, it just downloads a binary. But even there, you will be sure it will always be the exact same version to make sure your system is in exactly the same state. And I'm not sure that's always desirable, but for certain things that is definitely helpful to know that if this config file is applied to my system, I know that my tools will work because they have worked on these exact versions for the previous past 4 weeks. There's lots more to talk about, but I think I've fanboyed enough for this episode, and I will link to a couple of interesting things to look at for folks who got successfully nerd sniped by this.
And in 3 episodes later, you'll tell us about the new build system that you're really excited about.
It does feel a bit like it, right? Because I did Bazel, now I did Nix. I did feel a bit bad, but at the same time, you know what? No shame.
No, absolutely not. No, you have successfully nerd sniped me. I'll do a Docker thing at the very least. I'll spend time I should be doing, working on the thing that I've already started. Playing with a new thing. Yay, that's a developer life.
It is. It's the best part of it, I feel like sometimes. Well, after your episode we had to digest, I definitely now need to digest my own episode. So I think with all that being said, with all that being shared, I think there's nothing left to say except for happy next time.